Alright, good day students. We're going to start by taking a look at the formulas for growth and decay, and then we're going to do 3 examples, okay? So write down the title, growth and decay formulas, okay? Growth and decay formulas. Growth and decay formulas. Alright, we're going to separate them using the matrix. We're going to do growth and then decay. So you can draw a line like this. Put it like that. We're going to have growth first. And then we're going to have decay. Okay? Growth and decay can either be continuous, or it could be discrete. Okay? So what are the formulas for continuous and discrete growth and decay? Really discrete. Okay? If it's continuous for growth, you're simply going to have, you can have y equals y equals a e to the kt, or y equals ae to the rt. Okay, e to the rt. And then for decay, it's going to be y equals ae raised to the negative kt, or y equals ae to the negative rt. Alright, now for discrete growth, we're going to have y equals a times 1 plus r to the t, and then for discrete decay, it's a times 1 minus r to the t. Okay? What do all these variables mean? A is the initial amount, R is the growth or decay rate, K is known as the decay constant, decay or growth constant. Alright, R normally has to do with money, business. It has to do with business. And this, in most cases, has to do with biology. Okay, because many biological phenomena, their growth is continuous as opposed to money. That's more discrete. Y is the final amount, and T is basically time. It could be hours, it could be seconds, it could be days, years, whatever the time measurement criteria is. So that goes your matrix of formulas that we're going to be using for today. Okay? So let's take a look at example number 1. Example 1, erase this. It says, all life on Earth contains radioactive carbon-14, which decays continuously at a fixed rate. The half-life of carbon-14 is 5,760 years. Find the decay constant and write the decay model. So this is a decay scenario, so we're going to use the decay formula. If you look back, the decay formula that's continuous is this one right here. So these are the ones we're going to be using. So we're going to be using the decay formula for continuous decay, which is y equals ae to the negative kt. Alright? We're going to list what we need and what we know, and then we're going to find what we need. Okay? We should have only one unknown, so we can solve it since we have one equation. Alright? So let's do this. We're going to have, let's see, since it's half-life, a is equal to a, y is equal to 1/2 a. K is the decay constant, so I don't know what K is. T is 5,760 years, because that's the only time the unit in the question. Alright? So we're going to put all this into this equation and look for the missing variable, which is K. So let's do it. We're going to have 1/2 A equals A e to the negative 5,000 negative 5,760t. No, 5,760k. Okay? Alright, so to do this, we're gonna first of all get rid of the a's, divide both sides by a, divide this by a, and divide that by a. So this a cancel out, and that a cancels out. So we're gonna have 1/2 equals e to the negative 5,760k. Now, how do you get rid of e? You use natural log. So you take the natural log of both sides. So natural log of 1/2 equals the natural log of e to the negative 5,760k. On the right side, the ln and the e cancels out. So we're left with natural log of 1/2 equals negative 5,760k. Now to get the decay constant, we just simply divide both sides by the coefficient of k, which is negative 5,760. So divide both sides by negative 5,760, negative 5,760. Cancels out. And then you're going to be left with k equals the natural log of 1/2 over negative 5,760. So there goes your decay constant. To find the approximate value of this, we're going to use our calculators to do that. Okay, so we're going to do the natural log of 1/2, natural log of 1 over 2, close that, divided by negative 5,760. Answer is is e to the negative 4. So we're gonna write this as a decimal. So that means you're gonna have move it forward 4 times. So that's gonna be approximately 0.00012 yeah, 0012. Okay, so yeah, in the calculator, I have to move the decimal point forward three times. Because you had 1.2 in the calculator, 1.2 e to the negative 4. So that means you're going to go forward 1, 2, 3. Oh, 4. 1, 2, 3, 4. So you have 3 zeros in front of your number. Okay? So there you have it. That's your K. So we have our K. Next thing we need is the decay model. So 0.00012. So our decay model is going to be what we get when we plug in K into the original formula. So if we plug in K into the original formula, we're going to have y equals A e to the negative 0.00012t. And there goes your decay model. So this is the B part. Alright, so this is the decay model. And this is your decay constant. Okay? Alright, now let's move on and take a look at the next example. Example number 2. Alright, says a radioactive substance has a half-life of 32 years. Find the decay constants for the substance in a decay model. Let me see. Other one. Let's do this one. I prefer this one. Let's do example 3. It says a certain bacterial strain grows continuously from 50 to 150 in 30 minutes. What is a growth constant? And write a growth model. So this one is a growth scenario, so we're going to use a formula, and the growth is continuous. Y equals AE to the KT. Okay? The initial amount A is, it started from 50, right? And the final amount Y is 150. That's where it ended in, right? So the time frame is 30 minutes. So our decay constant, I do not know what that is, so I need to figure that out. Okay? Alright, so let's go ahead and plug in these arguments and figure out what K is. So we're going to have 150 equals 50 e to the 30t. Alright? So let's get rid of this 50 first, so I can not take the natural log of e to cancel out this e. So divide both sides by 50. So 50 over 150 is 30, so have 30 equals e to the 30t. Now the inverse of e is natural log, so I take the natural log of both sides. Natural log of 30 equals the natural log of e to the 30t. Alright? So e and ln on the right side cancel out. You're left with the natural log of 30 equals 30t. Now let's get t by itself. Divide both sides by 30. And then we're going to have t equals the natural log of 30 over 3. It's not t, it's supposed to be k. K. Sorry. Let's make all these t's k. I already know what t is. T is 30. So k is basically, sorry about that, natural log of 30 over 30, which is approximately, yeah, on a calculator. I'm going to use my old school calculator here because I don't like what my TI is doing. Alright, so we're going to do the natural log of 30 divided by 3, divided by 30, which is 0.01133. Let me check this calculator, see how it comes out. Natural log of 30 divided by 30. Oh, not bad. 0.1133. Okay? So the decay constant is 0.11334. Okay? So K is 0.1134. And what is our model going to be? So this is growth constant. And our model is going to be y equals, the initial amount is 50, right? It's not a floating amount. Initial amount is 50. Let's verify. Initial amount is 50. 50 e to the k. K is 0.1134 times t. Okay? Anytime you're given an initial amount, it has to be inputted into the equation. But if you don't have an initial amount, then you can use a as the variable. Okay? So there goes your growth constant, and here goes your growth model. Growth. Okay? Alright, thanks for watching this video. Remember, it's uploaded on YouTube for your viewing pleasure. Alright?